Welcome to the Insightful Professor. Today we continue our examination of multi-table operations in SQL. We'll be introducing a technique called a subquery. Recall that a query involves a select statement where we retrieve data from the database. A subquery allows us to take a select and nest it within or embed it within another select. It's an interesting technique that we'll look at for retrieving data from one table based upon information present in another table. Before we examine our new topic, let's recap the idea of multi-table operations. Information needed from the database does not always reside in a single table. This is the nature of a normalized database, where each table is a representation of information about just one type of object. That object could be departments, employees, parts, or anything else relevant to the application domain. The basic select statement must be extended in order to retrieve information from multiple sources. In earlier videos posted on this channel, we covered join operations. This video will discuss subquery operations. Let's consider our motivation for a subquery. Sometimes the exact values that we need to specify a condition or predicate within a query cannot be specified at the time we write the query because we don't know what these values are. The values might be stored in the database, and these values could be subject to change over time. Consider, for example, the question of which course has the highest lab fee of all courses. This would be a relatively easy query to write if we knew what that highest lab fee was. But given that we don't know what it is, we first have to obtain that value, and then we can formulate the query to say, select the course where the lab fee is equal to this highest value. That highest value could change over time. If courses are reassessed and assigned different lab fees, then the highest lab fee could change and then be associated with a different course. So what we need is the ability to construct a where clause or having clause, the two clauses through which we can introduce some kind of a condition or predicate, and allow for these to have effectively an unknown value that is resolved by the system. So the unknown values can be determined through the execution of a query, and the result of that query would then complete the definition of this predicate. A subquery is the technique that can be used to obtain these unknown values. A subquery is a select statement that is nested or embedded within another select statement. Let's consider that example that we just talked about. We wish to identify the course or courses with the highest lab fee of all courses in the system. The query, as I said, would be straightforward. Select asterisk from course where lab fee is equal to, and then we insert the value of the highest lab fee. But given that we don't know what that highest lab fee is, we'd have to step back for a moment and run another query. We would say something like select max lab fee from course, obtain that missing value, go back and revisit the original query, and insert that value. The problem is we don't want to do this in two explicit steps. We want to perform this as a single operation or a single job submitted to the system. So if we do it in two steps, we have to remember that max lab fee, the output of that query, record that somewhere as we prepare to write the other query, and then insert that. It's two tasks being performed by the system, two tasks that we have to create, and we have to feed one task with the output produced by the other. So this could be both time-consuming and error-prone. What we want is some way to submit the entire request to the server and let the server feed the output from one query into the other query. This is one of the key ideas behind a subquery. So here's how we would accomplish this. What we have is, again, select asterisk from course where lab fee equals, but this time, instead of putting some kind of a placeholder and say, I'll get back to you once I know what that value is, we connect or relate to this the subquery that's going to obtain that value. And this subquery will then execute, produce the value, which will then complete the definition of the predicate. Lab fee is equal to whatever that value is. So observe that the subquery is placed within parentheses. It's kind of like an arithmetic expression where we're altering the order of evaluation. Whatever we place within parentheses will be evaluated before what exists outside of parentheses. Therefore, this will do exactly what we were describing and what we would like. It will evaluate the max lab fee first and return that to the main query, and then the main query or the outer query will execute using the value that was returned. So given the current content of my academic database, the highest lab fee of any course is a value of 500. So this subquery would produce the 500, causing the predicate in the main query to become lab fee equal 500. That would then be evaluated, and we would retrieve the course that had that value. So where can we include a subquery within the main query? Well, there are some different options here. We could complete the definition of a predicate by obtaining some unknown value or values from the database. This is exactly what we've just been describing. We could then place the subquery which obtains that unknown value in a where clause. Or if it had to do with an aggregate type of value, we could insert the subquery call within the having clause. Another possible use of a subquery, which affects where we would insert it within the main query, would be to produce a source of data that we could process with some additional operations. We effectively would take the result set of a query, say the result set of a subquery, and treat it as a table. This is referred to as a table expression. Where do you access a table? Well, you refer to the table within a from clause. This is the location within a select statement where we could insert a subquery which is going to generate a table that we can then process with additional operations. And finally, another concept here would be to obtain exactly a single value, which could then be returned as part of a larger collection of data. When we issue a select statement, we might say something like select employee name, employee address, and so forth. Employee name would be a single value, and it is part of a collection of values returned within the select statement. A value of this type is referred to as a scalar value, and it is effectively perceived as a table, single row, single column. Well, that's exactly what a query can produce. It can produce a table, and that table could contain a single row, single column, hence a single value. Such a query is referred to as a scalar subquery. We could use one of these subqueries within a select clause. So depending upon our goal or objective, we could include subqueries within a where clause, within a having clause, within a from clause, within a select clause. So these are all possible applications of a subquery. So we've seen one in action. We've talked about some of the characteristics. Let's take it a step further. In this subquery, what we're going to do is obtain the smallest lab fee that is not equal to 0. So the smallest non-zero lab fee for any course found in the course table. So the query operates then effectively at a group or aggregate level by invoking an aggregate function, min lab fee. So we're getting information which is characteristic of a group. Select min lab fee from course where not lab fee equal to 0. non-zero lab fee. But notice that the main query will consume that value to complete the definition of the predicate, lab fee equal to whatever the value is. So the main query operates at a different level of detail. What happens is this is operating on individual rows or at the row level. Quite interesting that we're operating within a single job or task submitted to the database at two different levels of detail, group or aggregate, and then individual row level. We can see here that the syntax for constructing a subquery is straightforward. However, the semantics of a query involving a subquery might require a little bit more thought. And that's part of what we're indicating here by operating at two different levels of detail. So notice also that this subquery is a little bit more complex in that it contains a where clause. So in general, a subquery can contain any valid where clause with any number of conditions connected with Boolean operators. Now, in our next example, we turn it up a notch. Here, what we're looking at is a subquery that obtains the highest lab fee of any course that is sponsored by the philosophy department. That value is then returned to the main query. But in the main query, we have a complex condition here. Not only are we consuming the lab fee that's returned by the subquery, lab fee is equal to whatever that max lab fee is, but we have another condition that must be satisfied. C department must also be philosophy. So we are selecting philosophy department courses that have the lab fee equal to the highest lab fee of any philosophy department course. So the main query contains additional search conditions, in addition to what we see relating it to the subquery. The subquery is simply another condition, or creates another condition, which is connected to the main query's where clause. Subqueries themselves do not need to be written as the last condition. So we could have said where lab fee is equal to whatever the subquery produces and department is equal to philosophy. So the order in which we list these conditions is not important. Also observe that the same condition appears in both the subquery and the main query. This is due to the specific objective of this query, namely to identify philosophy department courses with the highest lab fee of all philosophy department courses. If we were to place the condition in only the main query or only the subquery, that condition would not apply to the other. So if we only said C department equals philosophy in the main query and omitted that condition from the subquery, it would not be shared, it would not be inherited by the subquery. Likewise, if we had placed the condition only in the subquery and not in the main query, it would not be shared by the main query. It would not percolate up. So what we look at is it's important to recognize that there are situations where we want to express the same condition in both the main query and the subquery. If we think about the order of evaluation, this makes some sense. What we're seeing is the subquery will execute first, and then we can think of that as being completely done with. It's produced its value, and now we're going to consume the value. So when we go to the main query, we're not going to remember that the subquery had a condition that said department is philosophy. That's why we must repeat it in the main query. And because the subquery can be thought of as almost a separate task detached from the main query, it's executed almost in isolation of the main query. So therefore, it doesn't share any conditions. In the last example, we demonstrated how to construct a subquery and showed that the syntax is really not that difficult. But we also raised the point that semantics enters into the picture when formulating a subquery. Sometimes the semantics can be quite subtle. Let's consider another example here. In this example, what we're doing is selecting from the course table, and we want only courses that are not sponsored by the CIS department. Additionally, we want the lab fee of the course to be equal to the result returned by the subquery. Let's consider a variation on this. This query is also returning courses from the course table that are not sponsored by CIS, not C department equals CIS. Additionally, the lab fee of these courses must be equal to the value returned by the subquery. The difference between these two queries is how the subquery is formulated. In the query on the left, we are retrieving the smallest lab fee of all courses. It doesn't matter what the department is. The subquery on the right is retrieving the smallest lab fee of only the non-CIS courses. So we can see that there's a difference in terms of what we've coded, but there's also a difference in terms of the meaning of these queries. So these two queries have different objectives, but they are sufficiently similar that ambiguity can occur unless the objectives are precisely articulated and understood by the query writer. If we were to run these two queries against my database, we'll see that given the current content of the database, these two queries, which are different, just happen to produce the same result. So the question arises, which one poses the correct question to the database? It depends on the precise objective of the query. Let's demonstrate these two queries by going to our database. The answer to our first query, the query that compares the lab fee to the smallest lab fee of all courses, reveals a philosophy department course and a theology department course. When we present the second query, we see the same result. The two different questions produce the same answer. Again, this is because of the current content of the database. Let's take a look at the data to understand what's happening here. Notice that the smallest overall lab fee is 0. When we exclude CIS courses, the smallest lab fee is still 0, but it's held by the two courses that we received as output in our queries. One philosophy department course, one theology department course. What would happen if these two courses had their lab fee values changed? For example, let's update the course table and set the lab fee equal to 1, where the course number is either P44 or T33. Now, when we examine the table, what we notice is the smallest overall lab fee. Any department is 0, and this lab fee is held only by CIS courses. The smallest lab fee held by a non-CIS course is 1. Now let's reconsider our two subqueries. In the first subquery, we said let's identify the non-CIS course that has a lab fee equal to the smallest lab fee of any course. That smallest lab fee is now 0, but none of the non-CIS courses have a lab fee of 0. So this query now produces no result. In the second query, we again are interested in returning non-CIS courses, but only if those courses have a lab fee equal to the smallest lab fee of only non-CIS courses. And now we get the same result that we had before. So the content of the database is an important point to consider in terms of evaluating whether we're asking the correct question. It's possible that we got the answer that we wanted, with the idea being the second query that's shown here is the query that we should have expressed. But given the content of the database, when we presented the first question, we got the answer we were expecting to get, but we weren't asking the right question. Again, this is the point of subtle semantics. I'd like to bring to your attention some additional considerations when writing a subquery. The examples that we've used have all accessed the same table in the main query and the subquery, but this is not a limitation of a subquery. Both the main query and the subquery could use complex SQL operations, such as a join. The examples that we've shown also have a subquery that produces a single value and the main query using a predicate with an equal operator to evaluate that single value. This also is not a limitation of a subquery. Any relational operator can be used to relate the value returned by the subquery. The restriction here, though, is that the subquery must return exactly one value in order to use a relational operator. We do make a note that it is possible using special keywords of any and all that there is an exception to this rule. We're not going to address the any and all syntax. A subquery could return more than one value that can be related to the main query, and this would require using the in keyword. If more than one value is returned by the subquery and an equal operator is used, the system will generate an error. Remember, the purpose of the in keyword is to examine a list of possible values and perform an equality test against each of these values one by one. In this example, we are returning department identifiers for those departments that are located in a particular building, the humanities building. So the subquery will return not a single department value, but multiple department values because we have more than one academic department located in the humanities building. The main query will then receive a set of values, iterating through this list of values, doing an equality test one by one. Note that in can be used even when only one value is returned by the subquery and an equality test is desired. So if you're unsure about the number of values returned by the subquery and you want to test for equality, feel free to use in to test for a match. It's possible for a subquery to contain another subquery. We had suggested this point when we indicated that a subquery can include a where clause. The mechanism that we've used to attach the subquery to a main query has been through the where clause predicate. We can extend this by having a subquery with a where clause receive data from another subquery. So it's possible to include a subquery within a subquery. There's no limit as to how many levels we can go. However, for practical purposes, we tend to cut this off at some point. Each new subquery must be enclosed with its own set of parentheses. In terms of evaluating a query that has multiple subqueries, the system will execute the innermost subquery first. So in this example, the innermost subquery determines the departments that currently offer 6-credit courses. With that information, now we can select from the department table, provided that the department ID is in this list of values returned by the subquery against the course table. This will then yield a set of faculty numbers for faculty members who chair departments. This list of faculty numbers is evaluated in the main query, where we then select rows from the faculty table where the faculty number is equal to one of those values. So the objective of this query can be stated as identify those faculty members who serve as the chairperson of a department that sponsors 6-credit courses. We've indicated that a subquery could be connected to the main query in a where clause. But we had also suggested that a subquery could be related to a query through a having clause. Suppose we wish to identify the departments that may be assessing a very high lab fee. We wish to determine the average lab fee of all courses offered at the school and use this as the basis for determining which departments have a very high lab fee. These would be the departments whose average lab fee is greater than the overall average of all courses. So the subquery determines the overall average lab fee, and this value is used to perform a group-level test among all intermediate groups. Remember, we're using the group by to group rows according to department, and then we use the halving clause to filter the groups that were formed. In this case, the filtering occurs by saying the average lab fee, it must be greater than what's returned by the subquery, which is the overall average lab fee for all courses offered at the school. So in this video, we introduced the concept of a subquery, also referred to as a subselect. We discussed the purpose of this, why we might use a subquery. We also explained 3 situations where a subquery might be used within a query. We provided examples of subqueries that completed predicates. This was one of the situations described. And we looked at this in the context of a predicate in a where clause or predicate in a having clause. In our next video on subqueries, we will discuss some advanced techniques, such as using a subquery as a table expression, and the interesting and sometimes confusing concept of a correlated subquery. If you found this video helpful, give us a thumbs up and consider subscribing to the channel to be notified when we post future videos. And once again, thanks for watching.